tell you all a few little stories today and make some observations here, which is kind of what I do, and hope you're getting something out of these, because sometimes whenever I see these pictures and start talking, other things will come to me, you know. But this one here, to begin with, this car right here is parked in a neighborhood close to here, and somebody recently bought the house. The house had been bought and flipped, and it was a really nice house. And somebody bought the house, and as soon as they bought the house, just as soon as they bought it, they parked this car in the yard, and they put a battery on the trunk. And it's been like that for a couple of 3 years. Strangest thing I've ever seen. I mean, you know, the car parked in the yard is one thing, but what's the deal with the battery on the trunk? And anyway, so this car right here was not one that was out there. That's a Ford 500. And one of the vehicles, and this is the picture I took on one we worked on. You know, Mercury also had a car that was similar to this back in, this is like an 05 model. And that guy had busted this knuckle on the rear by running over a curb or something. It just popped right there like that. And I got to looking for one of these knuckles, and it was very hard to come by. And I managed to buy a used one from somewhere up in New Jersey or somewhere for like 75 bucks. And this is what it looks like before you put it on there. You notice that half moon shaped hole right there? This one here, see, this one here broke right there by the bolt hole on all that. And that aluminum part, they put a lot of parts in these cars that are aluminum and plastic and stuff because they don't want them to weigh as much. And so that's what they do on that. But that one there, we had to replace that part. And it was fairly easy to replace, but it was difficult to find. Now, there was another 500 that belonged to the lady that taught another one of the programs at the college, and her accelerator pedal assembly and throttle body, we wound up replacing that. She actually, it's one of them deals where sometimes her wrench light would come on and she would lose most of her throttle action and all that, and we got to digging and hunting. I actually had a Intero PDA scope at the time, and I wanted to scope those wires, the 3 potentiometers that were in here, and you know, while it was running on the car, I back probed them and all. And I noticed that while I had that Intero PDA connected to that accelerator pedal sensor, and I was watching all the pots at one time, you could mash the pedal and the pots would read, but with that scope hooked up, the car would not respond to the accelerator pedal signals. I guess the Intero was creating just enough interference there to where it wouldn't do with that. And I don't know that a Pico scope would cause that problem, but that Intero scope, which I loved that scope, it was a really good one. Cost a couple $1,000 new. But we went ahead and she said, well, let's just go ahead and replace the throttle body and the accelerator pedal. And it was $145 for both of these parts from Ford when we were doing this job. Now, this was several years ago. And so I thought, that is an awful lot of hardware for $145, and she was more than happy to do it. Well, to our shame, we found out that she had actually had an accident, and because of her accident, and you couldn't see it unless you looked real careful, there was a wire that was rubbing down there, and it turned out she really didn't need these parts. But she said just leave them on there, they're new anyway, and we fixed the wire, and then all of her wrench lap problem went away. But anyway, the reason I told you that, $145 for the throttle body and for this, for the pedal assembly, which we bought them both at one time, that's what she wound up paying. This Toyota Camry about the same time was in the shop, and it needed this vapor sensor. That vapor sensor is mounted right up under here on this 98 Camry. And it was $190 from Toyota for that one little part. And that thing was big. I mean, as a matter of fact, you could almost, and I'm going to say almost, you could almost put that whole part in your mouth and close your mouth and nobody would know it was in there. That's how little that part was. But Toyota really hammered us for 190 bucks. So if you look at the difference in the price of the parts, both of these for 145, that one little bitty part for 190, seems like they could do better than that. Now, I will tell you that you can buy one of these now on eBay and other places for less money than that. You can get them pretty cheap, these vapor pressure sensors, because there's a lot of these cars that have died. I see these cars sitting in the weeds and stuff out there. Now, this right here was only expensive when it was misdiagnosed. If your on the cars that have distributors and rotors. You know, a lot of you guys, if you're really old like me, you might remember the old Chevy HEIs, and they would burn through the rotor when the spark plugs got too much resistance in them, and whenever those rotors burned through, you'd have a no start. Well, when this kind of rotor burns through, what you have a lot of the time is you'll have it'll idle, but when you give it the gas, it falls on its face because it's not punching through until you give it the gas and increase the load. So I found out when I was first working on one of these, I was working on a Mercury Tracer, and it didn't have a rotor exactly like this, but it had one vaguely similar to it. And I noticed when I partially choked off the air going into the air intake, it would rev up just normally. But if I moved my hand, it would do like that. So that's leading you to believe you got a fuel problem when actually it's an ignition problem. My buddy over there, he wound up working on one that was came off of a V6 engine. He worked on that doggone thing for half a day trying to figure out why it wouldn't take gas unless he partially stopped up the air intake there at the throttle body. And I told him, I said, you better look at that rotor. He wouldn't pay any attention to me. He cleaned the injectors, he did all kinds of other work, but he still had the same problem until he pulled the distributor cap, pulled the rotor off. See how it burned through here? You can see it really good there, and then here where it went through the other side, it was punching through there. You know, I actually I'm holding that little tang that, you know, rests against the coil puck. I'm holding it out of the way so you can see that. But anyway, that was a pretty interesting little situation there. And I saw that not very many times, but when you saw it, it would just about always beat somebody up, and they'd spend a lot of time and money that they didn't have trying to fix it, when this was actually what was wrong with it. I don't know if any of you guys have ever seen. I think there were some of the Jaguars that used to give this trouble back in the day, you know, long years ago, and they would use some epoxy to fix them or something. But this right here is an expensive mistake, and I thought it was interesting that in a Dodge shop manual, I found this illustration here, and you notice that the press crossbars are right here. You notice how they got them illustrated right here? They've got these bolts running sideways. Anybody that's used a press very much knows that if you're pressing something that takes a lot of pressure, and you put it like this, now whether this is flipped over or not doesn't matter. You know, this is not a problem. But, you know, because most of the time people like to do it like that if they can. But if you put this sideways and you got something that's going to have to take a lot of pressing, you're going to bend these bolts. And the reason I know that is because I did one time. I had one I was pressing, it was pretty hard, and I put that thing crossways like that, because sometimes you'll even see it in a book. This one here is done the wrong way too, see. This bends the bolts on a hard pressing operation because it causes it to go like this. Well, the right way to do it is like this. You notice this one here's got these two heavy pieces, and this is laying across them so that this heavy part of this bearing splitter is taking the load for that. And so it's real easy, you know, just to say, well, I'll just put this together and lay it across there, especially if you see it in the shop manual that way. It boggled my mind that the shop manual had that thing in there sideways. Of course, that one probably wouldn't have to do much pressure. But there's no reason, you know, sometimes we'll take these and stand them up because you're going to have room for this to come down where the bearing will clear or whatever. And so, but anyway, that's just, they also have, of course, it looked to me like it would be a bolt bending proposition too if you use these threaded holes and a puller, because you'd be pulling on that. It seems to me like it would do that too. But anyway, on the press, I'm always going to put them like this instead of like that or like this. And see, that one, this is the same kind of splitter, but it's flipped over and all that. So anyway, now this right here, this lettering the coils is something I just really don't appreciate very much. You can understand it if they lettered the coils, A being 1, B being 2. That's usually how it is on a Toyota or something like that. Cylinder number 1 be A, cylinder number 2 B, and on down the line. This one here, we got these replacement Motorcraft coils for Crown Vic. Okay, so you got one of these on each side. Okay, and you notice how this is marked 6 and 7, this is marked 2 and 3, that's marked 8 and 5, that's marked 1 and 4, right? All right, now, if you know how the cylinders are numbered on a Ford, the passenger side is 1, 2, 3, 4, and the driver's side, you know, I'm talking about a north-south engine now, not a sideways engine. The passenger side is 1, 2, 3, 4, and the other side is 5, 6, 7, 8, the driver's side. And what you would do if you were putting plug wires on one of these Crown Vics that still had these coil on plugs, and excuse me, not coil on plugs, but coil packs, is you would take the longest and the shortest plug wires and put them over there on the passenger side when you sorted them all out, and all the rest of them went on the other side. It's pretty easy to do. And then this one right here would be 1 and then 3. See, basically I got, see, 1, 3, and then 4 and 2, right? Now look at that. Isn't that interesting how they got that? Now, is this is for a V8, right? You got it. Now this same coil also went on 4 cylinders. So what the heck is this? Now look at this one here. When we bought this to replace this, let's say that's 1, but wait a minute. These are drawn a different way. This actually looks to me like it should be down here and flipped over. All right, but if that was the case, 1, 2, 3, 4, that'd be A, B, 1, 2, 3, 4, 5, that would be 5, that would be 1. Right, but notice where 5 and 8 is over here. Are you going to use this right here to determine which plug wire goes where, and you've got letters you're having to deal with instead of these numbers? See, I actually bought this to replace this and was totally surprised to get a Motorcraft that had letters on it. And we got A, B, C, D, E, F, G, H. All right, see if you can figure out a way to make that work. If A is 1, 1 is down here. And then 2 is here. All right, where's B? B is here, right? I mean, it's almost like if you flip those over, it would almost work, but then this one here is in the wrong place. That's just mind-boggling to me. I mean, we made it work, but golly, you know, why couldn't we actually make the sticker that had the same lettering on it? Because this is important. We don't want to hook those up wrong. It was kind of funny. One time I crossed the plug wires on a Taurus strainer car. I had a 3-liter in it. Of course, it had the coil packs with the 3 coils in it. And as soon as I tried to start the darn thing, it kicked back. And when it kicked back, because I had the plug wires crossed, I was planting a bug for the students, right? That thing kicked back and it busted the starter as soon as it kicked back, and the starter wound up hanging by the wires. But that was disastrous to bust the starter just because I crossed a couple of plug wires. You never know what's going to happen, you know. Now, I took these notes and a lot more notes in this blue notebook right here that I had at the General Motors School in Houston, Texas. I've still got this down there in my shed somewhere in a box, this entire notebook. And it had all of these. I always take lots and lots of notes when I go to a school because I find out I remember the stuff better when I write it all down. But I had something about checking the engine coolant sensor here and all of these numbers and so on and so forth. You know, this right here is just something that was stuff I wrote a long time ago. And I thought it was, the information is outdated because it was about computer command control. But that was a really good school, and I had a really good instructor, and I learned a lot about closed loop fuel control that I never would have known for a long time after that if I hadn't gone to that school. And I've always been grateful for that. Now, I taught my students how to test for alcohol and gasoline. And basically what you do, you're going to get a graduated container. What I did for these guys is I went ahead and went to Lowe's and I bought some rain gauges, and I used a tape measure and a Sharpie, and I actually put 10 graduated marks on the side of that thing so that they would all be the same. All right, and so what you do there is you got 10 graduated marks on here that are evenly spaced, and you can also get these little graduated containers like chemists use and stuff like that. And I'd have various different samples of gasoline here, some that had more alcohol than others. And I would want them to tell me how much alcohol was in each one. And so what they would do is they would take it and put 9 units of gasoline in there, and they would follow up and put 1 unit of clear water. And then they would put their thumb over it and they'd shake it up. And then they set it down, and that alcohol likes to mix with the water better than it mixes with the gas. And however much alcohol, in other words, you could see the water at the 10% level because you poured that much in there. And so however much water you gain is how much alcohol is in that fuel. So if you gain 20%, you know, over the original 10, that means that that gasoline is 20% alcohol. Now this is an interesting study because you can go and buy gas, little samples of gas from this gas station and that one, and not just about all of them will say may have ethanol in there. And you can do this test and you can see how much gasoline, how much alcohol is actually in that gasoline. You know, a lot of the stations will sell what they call ethanol-free gas and they charge more money for it. Well, if you go to the station and you buy some ethanol-free gas and you buy some gas that's supposedly up to 10% ethanol, then you can get some of that E85 if you want to buy a little sample of that. And you can run this test on that using a graduated cylinder. Now, if you're making your own graduated cylinder out of a rain gauge, that's, you know, it's got to be the same size all the way up and down. Or you can get anything, even like this little bottle right here. If you took that one and you made 10 evenly spaced graduated, and you don't peel the label off, that little oil, you know, shredder oil bottle, you can actually make your own. You don't have to buy anything to do this. And it's really handy to be able to check the gas and see how much alcohol is in it. You know, if you put alcohol gas in some of these lawnmowers, the little O-rings and stuff are attacked by the alcohol and they die. But you can put Marvel Mystery Oil in there and that supposedly takes care of that problem. Anyway, I like putting Marvel Mystery Oil in the gas in my lawnmowers anyway because it kind of top lubes them and it also stabilizes the gasoline for when you're letting it sit all winter. Okay, but you can freeze that and look at that, you know, and get an idea of how that's supposed to work. But these guys right here were using these rain gauge things and learning how to do that. This is, sometimes you just got to stop and take a picture. I was in Lowe's one day and this double nickel 55 Chevy was sitting out there and I said, man, I just love that car, so I went ahead and snapped a shot of it. And it's looked like it got a scratch down the side, but other than that, this is a pristine looking car and it's got them fancy mags on it and all that. Every now and then it's like that one there has managed to avoid the barn and the sitting in the weeds. Either that or somebody dragged it out of the barn and got it out of the weeds and all that. This is stuff that collected on my teaching desk. You know, I would teach and I'd like to have stuff out here in front of me where I could just pick it up and show it to them, you know, and different kinds of relays, and there's a lock cylinder and there's an oil pump that was all wiped out. This starter relay off of a Chrysler is a lot of fun to play with. Throttle position sensor, bent valve, and had a piston there, you know, where I could pick it up and hold it and show stuff like that. And that's a little AC door motor, you know, that's a little power window switch, and that's a CV joint out of a Volkswagen Bug or a Rabbit, whichever it was, I can't remember, and that little fitting there. But anyway, I had a lot of other stuff down here you couldn't see. But all of that stuff wound up getting, there's my little juice box that I had that connected to a 12-volt power supply under there. And there's all the computers that we used in the classroom and everything. Now, something you wouldn't expect. Look at this right here. This is on a transmission in a Dodge Dakota. And it's what we would call, I think it's an A500, and then there was an A518. But we also, back in the day, before they had overdrive in those transmissions, we call it a Nano 4 torque flat at 727 or whatever. This one here is the one that had the overdrive in it. And this guy was rebuilding this transmission, one of my students was, and this kind of looks like how this is supposed to be put in there with that in there. But the deal is, this is the right way with this wire. This right here fit right in there. See that, how perfect it was? But that wasn't the right part. And that screwed up the spacing. So anyway, if you look at that, sometimes things aren't always, you get used to seeing this and you think that's the way it's supposed to be on every transmission, but you got to pay attention when you're taking them apart, or you're liable to take this out of there and put that back in there, because a lot of times you slept between the time that you pull them apart and put them back together. I worked with a guy back in the 70s. He used to do a lot of automatic transmission overhauls back whenever those GM transmissions, you know, were real simple. And he could take one of them 350 turbo hydramatics out of a car and strip it down, clean everything up, and stack it back together with new parts. And whenever he got through ready to put the torque converter back in it, it was still warm. I mean, that's how fast that guy was rebuilding one of them transmissions like that. But he'd done so many of them, he just knew them really well. All right, look at this right here. These are thrust bearings. Now, if you're somebody that's thinking clearly, you ought to know that this right here is right and this is wrong. reason I'm saying that is the same guy that was building that other transmission took one of these bearings right here, and he put it in there upside down like this, when it should have gone in there like that, and that bearing came all to pieces and filled that whole transmission up with all kinds of metal, and we had to work on it a long time before we ever even halfway got it straightened out. But pay attention to that thrust bearing, because it'll fit either way, but it will only work right one way. So you basically want it so that this will carry the load, and that's against here. See how you can put that. Now I demonstrated this on a torque converter that I had cut apart, and this is actually the stator. So you're not going to take a torque converter apart unless you're working on a big truck, as far as that kind of thing goes. All right, now then, this right here, I ran into this situation that was very unusual at this. It was at a Nissan dealer. They had a Ford truck on this lift, and facing it right across the shop, they had a Chevy truck. And I had seen this on a Chevy trainer vehicle that I had, that I thought it was very interesting, that whenever we would raise up that Chevy trainer vehicle, it would always sag in the middle. That was the weirdest thing I'd ever seen. And this one here was straight and solid. Never look, but you can look at the difference whenever you raised it up. You could see this right here sagging down, like the frame was kind of weak. My friend over there has a tire store, and he raised one up on one of his lifts, one of these Chevy trucks that had a bunch of weight in the back of it, and the weight in the back of that thing literally broke the frame in half, and his insurance had to pay to get the frame replaced under that truck because it couldn't handle that, which I thought that was very interesting. Okay, now then, this crack, and you can't see it good, this is a close-up picture of but a radiator developed that crack right there. And it was in a place where it was really hard to see. That's one of the reasons that whenever a vehicle's got some high mileage on it, if you can get a good quality radiator, if you just buy any radiator that you can grab that they say will fit, you may be disappointed with it, because some of these Chinese radiators, the spacing right there where you put the radiator cap on won't even be right. And because you'll have the cap put on there, it won't fit tight because the little sealing surface is too far down. I've run into that before. Put a brand new radiator on one, she came back and it was percolating, and I noticed there was no spring tension on the cap whenever I pulled it off. And so I actually put 2 gaskets on the cap to give it some more spring tension, put it on there, and it didn't percolate anymore. That radiator had to be replaced because it wasn't made right. On my Explorer, I had to replace a radiator. It was had a lot of years on it, but not that many miles, because it started leaking. And I had to go through 2 or 3 replacement radiators from the parts store, and every one of them would leak. And I wound up finally having to get a radiator from Ford to put back on it. And that's the one that's on it now. This one here, if this radiator cracks, and you got all this hot water going through this plastic, if that radiator cracks without warning on a long trip on an interstate, and somebody doesn't happen to be noticing their instrument cluster gauge, they're going to cook the engine and maybe out in the middle of nowhere where it's really dangerous at the time. That is a nasty situation right there. But that's when I snapped a shot of that had a radiator crack. This one guy, this friend of mine, had this 93 Camry that his radiator split along the top of the tank, and it overheated on him. And when I got out there, I think I mentioned it before, I would have sworn in a court of law that head gasket was blown because it was puffing out like that video I just posted, that mashup video. It was puffing out that radiator cap when I went out there to check it. It was still really, really hot, and that sickly sweet smell that you get whenever you get a blown head gasket. Well, we went ahead and got a wrecker to bring it on over to the shop because it's about 10 miles. And I was going to show the students what a blown head gasket acts like, because I was absolutely sure that head gasket on that Camry was going to be replaced. Well, that doggone thing, apparently, whenever it cooled off, it sealed back up again, and it never puffed anymore. And I put a radiator in there, and he drove that thing for a long time. But that business about it puffing and huffing and acting like they had a blown head gasket when it didn't just boggled my mind, There was another one that I mentioned in a previous video. This guy gave the department a Bronco with a 5.8 in it, and because he said that the water pump had been leaking and he didn't replace the water pump, and he felt like it had overheated and blown the head gasket. And when you cranked it up, it didn't run all that great, and furthermore, it would start puking water out the radiator neck like it was, you know, had building pressure in the cooling system. I said, well, we're not going to be driving this thing on the road anyway. We're just going to be moving it around out here in the lot and back and in and out. We'd pull the transfer case out of it and all that when we were in the manual transmission drivetrain. And one day we decided, you know, we never really warmed it up enough to keep the plugs from getting fouled by cold enrichment. So I told one of my guys to pull plugs out of it. And he said, well, this one's got a 5.8, mine's a 5 liter. He had a truck in a 5 liter. And I said, wait a minute. And this guy on the cap, he had it numbered 1542638. And I said, that's not the firing order for this 5.8. It's a 137265548. You know, like a Mustang 5.0 would be. So I went ahead and got the another distributor cap, and I wired the thing up 137265548, which was the right way, and that thing ran like brand new. And it, matter of fact, after all these years went by, the guy that's the adjunct instructor that was my first graduate and all, he had got 10 years in the field, and he went back and he was farming part-time and adjunct instructor. Whenever they auctioned off that Bronco at the college, he bought that Bronco and he drives it on his farm and uses it to pull heavy trailers and stuff with, and that thing is still just like brand new. And we never had to do anything to the head, see, because all that puking business, when we got the plug wires wired up right, we never got any of that. That guy gave us a Bronco because he wired it up the wrong way and was assuming it had a problem that it didn't have. You know, people can convince themselves that they've got a problem or that they know what's wrong with something, and any of you guys that work on cars for a living will know that somebody will come to you and they'll say, oh, I know what's wrong with it, this is what you need to do to fix it. And then whenever you do what they said needed to be done to fix it, it's not fixed. And then they're mad at you even though they told you what to do to fix it. You know, what we always did was we'd say, well, we're going to take your diagnosis or your idea about what's wrong under advisement, but we're going to check it ourselves and see what we find. And, you know, because, I mean, people just convince themselves that they know what's wrong with it. It's real easy to do that, and it happens all the time. Now, this is what happens when you go mudding. If you're driving through a lot of mud, you notice how this is hard. This is a crown. This piston is, it's got mud and crud all up in there, and this boot is busted, and you got mud packed all in here around the brakes and all that. And look at that. You got mud packed into the rotor and all that. That is an absolute disaster. It makes you just want to take the high pressure washer and clean it all up, and then pull it apart and clean it some more, and then put new calipers on it and all that kind of stuff, and just fix it right up. You know, doggone it. But that's the kind of thing that a lot of people don't think about when they go in the mud. It's how that stuff splatters up in there, and it gets in. Yeah, you got sealed bearings and stuff, but there's other stuff that could be damaged by the mud. Now this right here was Teletouch transmission control on a Ford Edsel. Alright, that was pretty darn cool. The Edsel didn't last very long before it went away. You know, Edsel Ford was Henry Ford's son, and he came up with these ideas. And this was interesting here because you had park, reverse, neutral, drive, and low, and that's how you change your, you know, a lot of cars had push-button transmissions, but this one here had them right there on the middle of the steering wheel. You know, nowadays they put a knob down here on the console for that. I always kind of enjoyed either having a shifter in the floor or a pendulum stick on the dash or whatever. But this particular one, on the side of the transmission there was a motor that was supposed to shift the gears for you whenever you pushed whatever button you wanted. And sometimes those motors would get to where they wouldn't shift the gears, and you'd get under there with a hammer because they didn't have permanent magnets in them. They were wire wound. And you'd get under there and you'd whack them with a hammer, and then they'd start working again. Your shift motor. Now the cool thing, another interesting thing about this Edsel was it had this saucer style speedometer that would turn. The needle sat still, but the speedometer would turn as you got going. That was just really cool, I thought. But anyway, that's one right there that's in a car show or something. You know, there's still more of those cars out there than you would think there are. All right. This was one of my guys doing the fan board. You know, I had these 3 relays up here, and basically I had this switch here, that switch here. When you wired this thing up according to the schematic you had, you would be able to turn this thing on, and these fans would come on, and they'd run in series, which means they're both running on 6 volts, which means they're running half as fast. Then when you'd push that button right there, they'd kick on high, so that, and the relays, the way you had them wired up, would cause them to both run parallel, And that's how GM and some of the Fords have there's a bunch of other ways they're wired up. Hyundai apparently had trouble coming up with that. That 06 Sonata that we had a crazy wire up for their fans. It was like they couldn't figure out how to make it work, so they just cobbled together a bunch of stuff and put it in one box, and it was a disaster trying to figure that one out. But the long and the short of it is, this is a simple way of doing this, and it makes a lot of sense. Now, whenever you could watch this guy wire this up and still not know how he did it, because this looked like spaghetti when you get it wired up. I had a fuse right here in case something happened and they pop a fuse. And then on the back of it back there, I had a jumper box like you jump off cars with, and that was where the power came from. And so that was a really good quality trainer that I built. I bought 2 of those fans and these relays and their little sockets, and these, I just cobbled all this together so that you could look at the stuff on the board that you were hooking up with these jumper wires. And it taught those guys how those fans work, and if you can wire them up, you can usually figure out how they work. One guy got to where he could wire it up really good, and I had some holes in the back of the board. I don't know why I felt like I needed to do that, but I used hole saw. He laid his hand on top of the board while he was running the fans, and the thing clipped the end of his finger, knocked his fingernail off or something. So I put some netting on the back of that board to keep people from accidentally getting their fingers in there. I never expected that guy to do that. But this one here was the board that I built for fuel injection, and it's basically got the crank wheel down here, and you wired all of that stuff up. Basically, each one of these would tell you which pins, and when you wire that up, and you wired up this little OBD port, you could plug in a scan tool, and I put a fan right here, and so whenever you applied the throttle, that mass airflow sensor would have air pulling across it. Now, it wasn't exactly right, but it worked okay. And you could connect I actually had little LEDs in here where they would start blinking all at the same time when you first started spinning it over. And then, there's a key switch here, you turn it, and this button right here is where you'd mash that button to shut it all down. But when that thing started spinning, all of these would blink together, and then they would start firing sequentially. Now, this was off of a 98 Explorer, but it was very instructional. Didn't cost me anything, because I got a 98 Explorer that a buddy of mine had. It was wrecked. Got all of the engine controller and everything off of that, and I closed up the back of it so people wouldn't be in there messing with the circuits. That coil right there, I had it fixed so that these would just fire to each other. I had some plug wires cut off that were pointed at each other like that. Well, one time I was standing right next to this board and I was talking about it while I had it running, and it was going just popping all of these. This was spinning and all that. Cool thing about that is you can start turning that with your finger, and then until it sees that missing tooth, it's the second time it won't start firing a coil. I thought that was pretty cool that you could demonstrate that. But anyway, that thing was buzzing, and I was standing there, and I probably was only standing about 2.5 feet from where this was buzzing these coils, and I started getting lightheaded, and I realized I was breathing pure ozone coming off of those sparks, and I had to shut that thing down because I was just really getting dizzy. It wasn't a good feeling either, But anyway, this is an electronic fuel injection board I built. If you buy one of these from a place that makes them professionally, they're wanting many thousands of dollars. And actually, the maintenance man brought this board to me. It was already built. I don't know what it was used for, but he brought this and said, they were wanting to throw this away. You can use it if you want to. And I covered each one of these with plexiglass, you might notice, so it would be more reliable than that other one. Now, this is my ignition board. I put that one together, very similar. I put an engine controller over here, and the only job the engine controller had was to fire the coils. And I didn't have anything else connected to that engine controller. Up here, I had this little spring connected to that, and you could basically connect power from right here to that little tab I had sticking out of that ignition coil. Once that was connected, and this connector here was plugged into that coil, with that thing right there, you could lick your finger and touch that, and then touch this, and go pap, 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 it would fire the coil. It's funny because I tell some of these students I was trying to recruit, like, who wants to make a spark with your finger? And they say, no, I'm good. And then I'd show them how you do it. You touch that with your finger, and you tap, that's where the pickup coil comes out of the distributor. Now that right there was an old Ford distributor, and then we would wire up. That's a Chrysler module, and we would use this coil with these 2 modules. And of course I had a fuse right here. And there's my B plus, my B minus for everything. Now this one right here, we would wire this up like it was supposed to be. I've got all these labeled, and the pins going off of a TFI distributor up here. And once you wired those up and you turned it through, if we would have to turn off the lights on those, you see these spark plugs going pop, 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 firing in order, because I tooled the plug wires where they look really neat. And this little crank sensor right here basically was hooked up so that I just got a wiper motor, which works really good, and put it in there. Use the hole saw, put it in there, and you can mash that button and that would start spinning, and then it would start firing those coils like that right there. This one right here, you'd have to wire up the E-core coil that would operate with the distributor cap and all that to operate those. This right here was a very instructional board. For a long time when I was teaching ignition systems, I had all these same components and I would lay them out on the table in there, and we would let the guys make sparks and all by hooking stuff up and turning, whatever and all that. But that was just a very interesting little thing. All I did was put this part of the ignition, the engine control pins 21 and 22, and then, your hot pins, and I think it's, can't remember those 71 and 97, I think were those, and then you just had to hook up one of the grounds, but the grounds were all clustered together right here, and that engine controller on the side was basically what it used for that. But what might happen because of this broken off plastic gear? Any of you guys that have done a lot of transmission work would recognize this as the governor for an old GM transmission. Comes in, won't shift, pull it out, you find out that this is busted off. Well, if this doesn't spin and those flyweights don't go out and move that little spool valve inside there, you're not going to get any shifting. And so that's what was going on with that one right there. Thought you'd appreciate that. This right here is my modified wrenches in a drawer of my toolbox. And what I had a tendency to do is heat these things up and bend them this way and that. I had more than just one or two of those in there. These right here is these ratcheting open-end snap-on wrenches like I bought a long time ago, and that right there is these line wrenches and all that. I got in that particular drawer. I got cheap wrenches and good wrenches and all that. That's an old Mac wrench that my dad set up shop with back in the early 1960s. He bought that off the Mac tool truck a long time ago. I'm kind of like him. I never really did like that 12 millimeter size because it's a kind of a Japanese size, and the Volkswagens and the other stuff that uses 8 millimeter bolts will typically have a 13 millimeter head on them and all. But anyhow, that is coffee time now. I really appreciate you guys stopping by, and I hope you'll come next time, and I'll see you then.